this video is to explain the power of a function rule. I assume that you already know the product rule, the power rule, and the constant multiple rule in order to learn this next rule. Rather than show you the rule and then give a few examples, we're going to do the examples first, show you the mechanics of how to get the answer, then we'll go over the general rule that works no matter what, and then we'll do one more challenging example. What I want you to notice first is that although these functions look familiar, they're different than what we've got the derivative for previously. The difference is we have one function all to the power of an exponent. And each of these examples are like that. In the past, we had an exponent, but we never had an entire function underneath the exponent. We just had an x or another letter, but we always had a letter to the power of a certain exponent. In order to get the derivative of something like this, we're going to do something that looks very familiar. So we're going to take that 9 and make it the coefficient, and then we are going to subtract 1 from that number to get the new exponent. The new part to learn is that we're going to keep the inside exactly the same, but we will have to get the derivative of that inside part. So we tag it on to the end. The 2x minus 1 came from the derivative of that inside part of this bracket. So the derivative of x squared minus x plus 5 is 2x minus 1. So it gets tagged on the end. The brackets in this case around the 2x minus 1 are very important. If you don't include them, it's not the same function. So please be careful with your brackets. If we follow the same strategy with the second row, we've got an exponent that's 11. So it becomes the new coefficient. And the new exponent is now 11 minus 1. So that's where the 10 came from. Inside the bracket, we keep the exact same function. And then we tack on to the outside the derivative of that inside function, which is going to be 7 times 6, which is 42, x to the power of 6. On the second row, you can see that the brackets around the 42x to the power of 6 aren't as important as the first row. Since there's only one term there, you didn't actually have to put them in. It would still have been correct if you didn't. For the third example, we might want to simplify a little bit first, or I guess simplify is not the right word, but rewrite our square root sign as a fraction. And you're going to see that we're going to do this constantly when we're dealing with derivatives, that we prefer exponents to root signs. So we'll do that first, being very careful to keep our page organized. That was still y, that wasn't my derivative yet, and then y prime, or the derivative, or dy over dx, is going to go over here, and we're going to follow the rule. So the exponent becomes the new coefficient, and then we subtract 1 from 1/2. So being really careful with this exponent here, that we're going to end up with negative 1 over 2. Inside the bracket, we just rewrite everything, and then we tack it on to the end. And the part that we tack on is the derivative. So just be careful. We take the coefficient to the front, we rewrite the inside part just the way it was, and we subtract 1 from the original exponent, and then we multiply it by the derivative of the inside part. So if we wanted to write that as a general rule, it would look like this. You'll notice that we have the original function being a g at x to the power of n. So g at x is that inside original function, and n is the new exponent. So if that's f at x, then the derivative, or f prime at x, is the same thing we did with the 3 examples. We take that exponent and it becomes the new coefficient at the front there. Keep g at x exactly the same. The new exponent is n minus 1, and then we're going to multiply by g prime at x. So we're just going to do one example, putting together a whole bunch of rules that we've already done. Okay, here's our example. You'll notice that it's a little bit more complex than the previous ones because what we actually have is one function with an exponent times a second function with an exponent. So hopefully it makes sense that we are going to have to do the product rule here. So when we do the product, we are going to get the derivative of the first thing, which is this first term. So in order to do that, we have to use the new rule that we just learned. So we take the 7 to the front, keep the inside function the same, reduce that number by 1, multiplied by the derivative of the inside, which is 3. So basically, we've just got the derivative of that star part. The product rule says get the derivative of the first thing, so we've done that, times the second thing, plus the first thing, times the derivative of the second thing. So now we're on the second equation, and we're trying to get the derivative of this. We will have to use the rule that we just learned again. So we've got the 4 as the new coefficient, subtract it by 1, and then multiply it by the derivative of that inside part. And that is our final answer. You'll notice that it's very common to get these really, really long equations. Please don't worry about expanding and simplifying. There will be some very specific cases in the future where we are going to simplify, but they're not going to look like this. So just leave it like that. In the end, these derivative questions are usually a one-step question. So once you get it all written out, you're finished. And that's it for the power of a function rule. You can add this rule to your pink sheet if you would like.